Hello, good day. Welcome back to my channel. I am your teacher Neil, and in this video, we're going to learn how to graph a circle. Are you ready? But before we start, so on your last lesson, I already discussed what are the different conic sections, the circle, ellipse, parabola, and hyperbola, and how they are different to each other. But now, let us discuss the first conic section, the circle. So let's begin. So in plotting a circle on a graph, it requires two things. First, a grid reference for the center point, and second, a radius. By definition, a circle is the set of all points the same distance from the given point, the circle's center. And a radius, or r, is the distance from the center point to the circle itself. On the graph, as you observe, all those points on the circle can be determined and plotted using x and y coordinates. And there are two expressions to show how to plot a circle. First, the center radius form, and second, the general form. So, in the center radius form, x and y are the coordinates for all the circle's points, and h and k represent the center points x and y values, with r as the radius. So that the center radius form looks like this. And in general form, it requires a lot more work than the center radius form to derive and graph. It looks like this: x squared plus y squared plus dx plus ey plus f is equal to 0. Where in the general form, d, e, and f are given values, like integers that are coefficients of the x and y values. And if you are unsure that a suspected formula is the equation needed to graph a circle, you can test it. It must have 4 attributes. First, the x and y terms must be squared. The second one is all terms in the expression must be positive, which squaring the values in the parentheses will accomplish. The third one is the center points is given as h and k, the x and y coordinates. And 4, the value for r or radius must be given and must be a positive number, which simply makes common sense. You cannot have a negative radius measure. The center radius form gives away a lot of information to trained eye by grouping the h value with the x. The form tells you the x coordinate of the circle's center. The same holds for the k value. It must be the y coordinate for the center of the circle. Once you figure out the circle's center point's coordinates, you can then determine the circle's radius. In the equation, you may not see r squared, but a number, the square root of which is the actual radius. So, try these 7 equations to see if you can really recognize the center radius form. I will give you a time to preview this video to see if you can recognize it. And if you finish, as you observe, only equations 1, 3, 5, and 6 are center radius forms. The second equations graph a straight line. The fourth equation is the familiar slope-intercept form. And the last equation is a graph of a parabola. Now, let's look at how to graph a circle. A circle can be thought of as a graph lines that curves in both its x and y values. To get a curve to graph as a circle, you need to change both the x exponent and the y exponent. As soon as you take the square of both x and y values, you can now get a circle. To plot that for yourself, recall the value h will be your x coordinate, and the value k will be your y coordinate. Together, h and k give you the center point. The radius will be the square root of the number on the right side of the equation. You can use a calculator to find that the square root of that number on the right side and use that as the radius. Whatever the unit of measure are in your center radius form, those are the units to use in your graph. So this means you may need a grid that is marked off in a very small increments like ones, and a very large units like hundreds. Often, the center radius form does not include any reference to measurement units like millimeters, meters, inches, feet, or even yards. In that case, Just use single grid boxes when counting your radius units. When the center point is the origin, 0, 0 of the graph, the center radius form is greatly simplified. X squared plus y squared equals r squared. For example, a circle with a radius of 7 units and a center at 0, 0 looks like this, as a formula and a graph. X squared plus y squared equals 49. Next, let's learn how to graph a circle in standard form. If your circle equation is in standard or general form, you must first complete the square and then work it into the center radius form. Suppose you have this equation. Rewrite the equation so that all your x terms are in the first parenthesis and y terms are in the second. You have isolated the constant to the right and added the values unknown 1 and unknown 2 to both sides. The values unknown 1 and unknown 2 are each the number you need in each group to complete the square. Take the coefficient of x and divide it by 2 and then square it. That is the new value for the unknown 1. Repeat this for the value to be found with the y terms. Replace the unknown values unknown 1 and unknown 2 in the equation with the newly calculated values. Then, simplify. So, you now have the center radius form for the graph. You can plug the values in to find this circle with a center point, -4 and +3, and the radius of 5.385 units. That is the square root of 29. So that's it. You can feel free to review this lesson anytime, class, to really understand how to graph a circle. So thank you for watching, and God bless us all.